Okay, welcome to part 2 of quadratic trig equations. We're going to look at a third and final example, which requires a little bit more work because we need to use our trig identities. More precisely, we need to use sine squared plus cos squared equals 1. That can be rearranged to sine squared is 1 minus cos squared. Let's look at this example. I've got 2 sine squared theta plus cos theta minus 1 equals 0. Now, because it's the sine that's squared, that is what I change. I can't really change cos. It wouldn't be very practical to use that. But if I change sine squared to 1 minus cos squared, everything is in cos. So let's do that. 2 lots of 1 minus cos squared theta plus cos theta minus 1 equals 0. Expand the bracket, 2 minus 2 cos squared theta plus cos theta minus 1 equals 0. Simplify further, so I've got negative 2 cos squared theta plus cos theta, 2 minus 1, positive 1 equals 0. Just like any quadratic, you want your squared, the thing that's squared, to be positive, and this isn't, so you can multiply everything by negative 1. So that becomes 2 cos squared theta minus cos theta minus 1 equals 0. And that's what we're going to solve. Now, a little tip, I always rewrite this. Some people don't bother, but I like to call it now 2c minus c minus 1 equals 0. Just looks a bit more like a normal quadratic, and I'm a little bit more confident factorising that. So let's put it into brackets. These will usually factorise if they've put them in an exam, particularly c equals 0. So I've got, I believe, 2c plus 1, c minus 1. And let's just double check that, 2c squared minus 2c plus c. Yep, everything is in order there. So that renders the solution c equals negative a half and c equals 1, or we can say cos theta equals negative a half and cos theta equals 1. Well, that's going to give us two sets of solutions. I'm just going to draw my cos graph. We're solving it between, you will be given this, you'll be given the range in which you're solving it. In this case, it's between 0 and 360. Well, I already know that cos graph in its primary period, which is between 0 and 360, starts at 1 and ends at 1. So my solutions there are going to be theta equals 0 degrees and theta equals 360 degrees. Cos is negative a half. Well, again, it's quite a nice one, this. Inverse cos of negative 0.5. And you've got 120 degrees there. Showed you the one bit of the calculator, but there it is. 120 degrees. So I've got theta is 120 degrees. There's negative a half. It's going to be about there. 120. Look at that. That's 60 degrees away from 180. So imagine going 60 degrees the other way. From 180, you're going to should get 240. You're just using the symmetry. Or you can do 360 minus 120. So theta equals 240 degrees. Again, I can't emphasize enough understanding how to find your multiple solutions with the graph. So let's just check these values. Cos 240, you've got to calculate your exam, so do check it, negative a half. Job done. Always check. If you don't check, you're an idiot. Right. There you go. Hopefully that one was clear. Thank you very much.